Welcome back, solving quadratic equations, this time by completing the square. I have done a couple of videos. There's basically a few ways of being able to solve a quadratic equation. And those particular ways are, number one, most of the times you will be taught by factoring. Now, when you're using factoring, it works out for some cases, but unfortunately for most cases it will not. And I will put up a link, so up above, okay, so that's going to be the factoring video. Another way of solving these quadratic equations is, which is probably kind of maybe the most useful because you get a visual sense, is by using graphing. So you know that quadratics are just simply parabolas. If you're going to be solving for a particular equation, then you're just typically finding if it's a quadratic which is equal to 0, like you see here on the screen, then you're really just solving for the x-intercepts, and then you can use graphing for that. So I'll put up a link up above. If you've forgotten, you can use graphing as a tool. Now, what happens if you can't use those tools? You know, what is available to you? Well, it turns out that probably one of the more kind of useful ways is by utilizing completing the square. So here you have a quadratic. Now these are actually the exact same equations. I have went from the standard form, which is x squared plus 8x plus 3 is equal to 0, and then I transferred it into the vertex form by just completing the square. And if you do that, then solving the equation is so much easier. Now, it also tells us when it is possible to do it or not. So for instance, if I would take this particular equation and then I'm going to now transform this by completing the square to get that. And then I will say that, okay, so let me now solve for x. The trick really is we're trying to find out what value of x is going to make this equation 0. Now, you can make it equal to anything you like, right? So on the right-hand side, it can be equal to something else, which is some number, but you can always bring that number over to the other side, to the left-hand side, and then it's going to look exactly in the vertex form or in the standard form equal to 0. Now, if you've forgotten how to complete the square, so here's, I guess, the other link. So I'll put up a link up above to the general completing the square. So you can look at that before you watch this video. I'm going to assume that you kind of practiced it and know how to do it. Once you're at this stage, then trying to actually solve for your unknown is we're going to be isolating for x. So I'm going to, for instance, bring the 13 over on the other side, which is going to become plus 13. On the left-hand side, I'm going to have x plus 4 squared. And now to get rid of the square, I'm going to take the square root of both sides, and that's going to leave me with x plus 4 is equal to, so now the square root of 13. Now don't forget when you take the square root of a positive number, so the answer is going to be either plus or minus in this case. In this instance, we actually have to keep them because the quadratics actually have two solutions, and those two solutions are going to be coming from this plus minus of the square root of 13. And now the last step is we're just going to move that 4 from the left-hand side over on the other side. So we're going to get x, and then if we shift this thing over, so we're going to get, I guess, negative 4 plus minus the square root of 13. So my two solutions are actually negative 4 plus 13, so that's one of the solutions for x. And notice, because of the square root, it's kind of an irrational number that you would have, and therefore that's why factoring, for instance, wouldn't have really worked, because to try to factor, we're used to factoring just with integer numbers. The other answer, so this would have been, let's call this x1, so the first answer, and then x2 would be the second answer, is negative 4 minus the square root of 13. So that's what you would have had. And these two particular answers, you can keep them as decimals if you want. You can take the square root of 13 and then round if you're in school, but I'll just keep it like this. So that is kind of the way in the process we want to go. So our idea will be is, number one, we're going to take our standard form, and we're going to take that standard form And then we're going to transition that standard form by completing the square. So we're going to complete the square. Okay, so that's going to be our step number 2. And then once we complete the square, then we can solve and then isolate. So it's going to be our step 3 for whatever our answer. And our answer is going to have these plus or minuses right here that you see, because we're taking the square root of one of the sides, which is just a normal positive number. Now, if for whatever reason, you're trying to complete the square and then, you start to solve, and then you bring over your number to the right-hand side here. And if this was a negative, so let's say instead of this being negative 13 here, because if we bring this over on the other side, then it becomes positive 13. But let's imagine it was positive 13, and then when we brought it over, it would have been negative 13. Notice, if we took the square root of a negative number, there is at least no real answer for us, which basically tells us that that solution, okay, so that equation doesn't actually have a solution, which is pretty useful. And you'll see that in one of the examples that I'll show you. So let's try these, okay? So let's try this method of taking a standard, right, form of a quadratic, completing the square, and then finally, solving it. So let's try to do that on a few examples. So I've prepared a few here for us. And so these ones, you can certainly try to use factoring. You're going to have a very hard time to try to factor these out. So factoring kind of is going to go out the door. Yes, of course, you can try to graph them, but sometimes on tests or quizzes, or sometimes on the back of the envelope as you're kind of doing things on your own, you may not be able to graph it. So I'm going to take these. All of these are in standard form, and they're all equal to 0. And again, if this was not equal to 0, if it was some number, so what I mean by that is if this was, for instance, I don't know, 1. Well, to make it equal to 0, just bring this always over to this side. So that would have been 9 minus 1, which would have been 8. And then you would have 8 is equal to 0 again. All right, so that's what you can always do. And that's why in school, most of the time, we're just simply dealing with these equations equal to 0. All right, and then what we're trying to find is we're trying to find the roots, or sometimes the zeros. That's what we call these things. So we're trying to solve for x, and because they're quadratics, there's always going to be 2 solutions, 2 answers, or maybe no solution at all. All right, so I'll take the first one, and I'm going to take this, and we're going to play a little bit of a completing the square. So it's going to be our first step. So let's take that, and then I'm going to take this right here and complete the square. I'm going to leave this 9 over on the side. All right, so in order to complete the square, I'm going to take out the 4. So that's going to be 4. And then in brackets, I'm going to have left x squared, and this is going to be minus. It's going to be minus 5x. All right, so that's what I have in brackets. And here, okay, it's going to be plus 9. So that's going to be my first step, right, from completing the square, as we recall. Now, the next step is I want to be able to take this inside of the bracket and basically create a perfect square. All right, so creating a perfect square, I'm going to have x squared minus 5x. Now, in order to complete a perfect square, remember, we take the value, so in this case, it's going to be 5. We divide it by 2, and then we square it, right? So that's going to be plus, so this is going to be 5, divided by 2 squared. And then, not to change the actual equation, we also have to subtract this, exact same thing. So that's going to be that, squared. All right, now this 4 is still in front of all of these brackets, and then our 9 remains on the right-hand side. And now we can complete our square. Now, completing our square, so this is going to be now a perfect square. So that's going to turn into, now the 4 stays outside, so x minus, and this is going to be, so 5 over 2, and this is squared. This 4 is going to have to multiply this right here, So that's going to be now minus 4. And this entire thing, so I guess it's 25 over 4. So that 4 is going to nicely cancel for us. This is what we have right there. Notice this 4 and this 4 is gone. And here we have now completed our square. 5 over 2 squared. And then this is going to be minus 25 plus 9 is equal to 0. And negative 25 plus the 9 is going to be, I guess, negative 16. I have 4x minus 5 over 2 squared minus 16 is equal to 0. So that's completing the square. The next step is, because we're solving for x, is we want to be able to move that 16 over on the other side. So the sign will change. So now we basically are going to solve. Now solving this, I'm going to bring this 16 over on the other side. I'm going to have 4. This is x minus 5 over 2 squared. Now we have this 4 in front of our brackets. I'm going to divide both sides by 4. All right, so I'll have that. So that cancels out. And here I'm going to have now x minus 5 over 2. This becomes squared. That's going to be 4 right there. Taking the square root of both sides, so that's that. It's going to leave me with x minus 5 over 2 is equal to, now the square root of 4 is actually 2, but it's going to be plus minus 2. All right, so that's what we have because we're taking the square root. So the answers are always plus or minus. And then finally we shift this over to this side. So x is equal to, so it's going to be 5 over 2 plus minus 2. So my two answers, okay, so from here, so my two answers, so it's going to be 5 over 2 plus 2, that's one answer, and 5 over 2 minus 2 is another answer. All right, now 5 over 2 is actually 2.5. So this is 4.5, and then this will be, I guess, 0.5. So those are my two answers that I have. So there we have it. Okay, so it's quite a bit of work for these, but they are doable. And notice we wouldn't have been really able to kind of factor this out unless we would have gotten into decimals directly. All right. Now, just as of kind of completeness, we can take this entire thing for ourselves, and then we can also graph it. Now, I know we're not using graphing here, but you can also just kind of check and see how this parabola looks like in terms of graphed form. So let me do that quickly for you. Okay, so there you have it. So I graphed it, and notice those are our two answers, 0.5 and 4.5 for x, and those are the actual x-intercepts that we would have. Okay, so quite a lot of work in order to get from the standard form and then all the way in terms of a solution, but this is actually how we can proceed with the solution if we wanted to. So let's do another example. So here is, I'm going to do exactly the same thing with that second example right here. Let's copy it down. Let's begin. So let's complete the square. All right. Now again, you can kind of try to see if maybe you can factor things out for yourself to make it a little bit easier. But it will turn out that if you try to factor it out, it may not work out so nicely for you. All right, so I will actually complete the square first. Okay, so first completing the square, so I'm going to take out, so this 3, I'm going to have x squared plus, this is going to be 4x because I took out the 3. And then I'm going to leave a little bit of space, minus 7 gets left behind there. Now the 4 divided by 2 is going to give me 2. So this is going to be 2 squared, which is 4. And then I have to put minus 4. So this one's a little bit nicer than the previous one. Now from here, this is going to be my perfect square. So that's going to be 3x plus 2 squared. Now, don't forget this 3 is going to multiply that, so it's going to be minus 12. Minus 7 is equal to 0, so I have that. It's going to be minus 19. I have now completed the square, and let's solve. So I'm going to bring that negative 19 over on the other side. So it's going to be 19 in this way. And here, so dividing by 3 on both sides, because I don't want this 3 right there. So that's going to be gone. Now, that 19 over 3, unfortunately, is not very pretty. So I'm going to just leave it as an actual fraction. Now, next, taking the square root of both sides is going to leave me with x plus 2 is equal to, so plus minus, square root of 19 over 3. And then bringing this over on the other side, and here are my two answers. So it's going to be minus 2 plus minus, and then this is 19 over 3. All right, so we have two solutions, negative 2 plus square root of 19 over 3, and then negative 2 minus square root of 19 over 3. And those two are actually pretty ugly. All right, now if I did that, let's do that right here for ourselves. Negative 2, so plus, and then it's going to be square root 19 over 3 equals, so that's one of the answers, that's the plus answer. It's going to be 0.5166, so on. And then the second one, all right, I'm going to try to cheat here a little bit. I'm going to put minus back in there. And that's going to be the second one, negative 4.5166, and so on. All right, so those are my two answers. And if you like, again, you can kind of graph the original just to double check. But of course, on tests or quizzes, you may not be able to do that. Or even if you're just kind of working on the back of the envelope or something of a scrap piece of paper, you know, you would kind of leave it like this. But this is perfectly okay. All right, so that's another example of being able to solve a quadratic equation by transforming and completing the square. Here's my last example. And this example will illustrate that although this process is great, you will find that when you complete the square, as I mentioned kind of in the beginning of this video, sometimes it doesn't really work out, and then there are actually no solutions. And for this one, I'll graph it at the end just so that you see that this actually won't go through the x-intercept, meaning, you know, that equals to 0 there. So I'll complete the square as I normally would. Now I don't actually have an a in front here, so it makes my life easier. So I'll have x squared plus 5x, and then divided by 2, so it's going to be plus, so 5 over 2 squared minus, this is 5 over 2 squared plus the 8. That's what I have there. I don't need any brackets because I don't have an a. This right here is a perfect square, so that perfect square is x plus, that plus comes from the sign of that, and then this is 5 over 2, which is 2.5 squared, minus, now this is going to be 25 over 4 plus 8 is equal to 0. I have that. Now this right here, now 25 over 4, all right, so that's the negative, now 8. If I want to kind of keep it in fraction form, right? So if I keep that in fraction form, so that means I can find a common denominator between these. So negative 25 over 4 plus, now making that 8 over 4, so that would have been 32 over 4. All right, so this is now going to be positive. So that's going to be positive 7. So plus 7 over 4 equals to 0. Now all of this stays the same. X plus 5 over 2 squared. Now it's plus right here. And this is where the problem is going to lie, because now if we try to solve this, we would move this over on the other side, and what you will find is it's going to become negative 7 over 4. X plus 5 over 2 squared. This is what you have. Because of that square root, we're going to be doing this. We're going to be trying to take the square root of that. And as you know, the square root of a negative number does not give you a real answer. There's no answer here. So once you notice this step, you basically say this has no solution. And in the physical sense, what it means is this quadratic, if you wanted to graph this quadratic right here, so this original quadratic, you would notice that it basically wouldn't go through 0. All right, so that just wouldn't happen. And let me graph it for you. There you have it. So it's a parabola going upwards. You know, we certainly have a vertex. I mean, we found the vertex, negative 2.5 and 1.75, but it does not go through 0. All right, so it has no solution. So we have found this entire thing. So right here, right? So we can see what the x-intercept here is. We know that it opens upwards because it's positive, but we have no solution. And that's how you use completing the square to actually solve these equations. So you can do it in 3 different ways. You know, factoring if it works. I mean, those questions where it works are kind of school related. You know, like you'll be lucky if it actually works out. But in school, of course, they'll give that to you just to test and see if you understand factoring. Graphing is probably super useful because it gets kind of intuitive and you understand the intuition behind these things. And then completing the square is super useful. And from this, the next video, if you watch this series that I'm kind of recording, you know, I'll show you the quadratic formula, which is going to be the 4th way, because there's actually a formula where you can find the solutions if they exist. And I'll try to derive that for you for those who are going to be interested. All right, thanks for watching. We'll see you in the next one, okay? Cheers, everybody. Bye.